So now in the last video, we looked at this circuit here. And it's pretty simple actually. We have a NPN bipolar junction transistor as a current source. So this resistor sets the current based on the voltage across it. The voltage across it, in this case, will be the voltage we set with a Zener diode minus about 0.6 volts. So we'll have about 5 volts across there. And in any case, we'll have 5 milliamps of current going through the load. We're just going to look at the current with the power supply. It's probably going to say 4, because if it's just a spec below 5, it says 4. It's not completely accurate. But in any case, that will set the current. So we looked at that in the last video, but we looked at the voltage across the resistor, how it holds steady, even though we kept changing the load, which changes usually what goes across series components. But this video, we're going to look at the voltage across the transistor, which is what actually changes the voltage across it to hold the voltage across all the other components steady. So now one thing we didn't do in the last video, so I'll do it now, is look at different supply voltages. So we had it at 15 volts throughout the whole video. This one, I'm going to start at 7, and there you can see we have the 4 milliamps is probably like 4.9 or something for 5 milliamps. But in any case, we have 4 right there with just one LED. So what I'm going to do is move the jumper up one spot. We're dealing with a 7 volt supply right now, and put another LED in series. So right now, these two LEDs, they're dropping too much voltage. We can't get enough power across the transistor and the current setting resistor, most specifically the current setting resistor. And so we just have to bump up the supply voltage. So you need, now we got 2 more volts, which makes sense because that LED was dropping about 2 volts. Now we have enough to get it to at least say 4, and it probably would say 5 if we had a more accurate meter right there, just a speck below 5 maybe. And let's put another one in series now, but it will be the same thing. So there you can see, again, we're about 2 volts shy, and so we go up 2 more, now it's 4, and then I can go up to 15 right there. And looks like we had a little spike where it went up for a little bit for some reason, but there you can see now it's 5. So I'm thinking that's because the transistor got a little bit warmer. And actually, now that I think about it, when we raised the voltage, we also raised the current going through that resistor, which sets the current through the Zener diode, and it also goes through base to emitter there, and then that will be a little more current. So not enough, but probably enough to make it go from 4.9 to 5 on the display right there. And now we have my pocket oscilloscope there. The end of the cable is the alligator clips. I clipped up the jumpers right there. I do that all the time. That way I can just move the jumpers to get our measurement points. Also, these are new LEDs. I haven't put too much current through any of them, so they're all equal brightness of each other. They're one color. I got the other new ones right there. They may look a little bit brighter than they did before because I changed the overhead light for the oscilloscope, so that shows up better. But in case, now we're going to go across the transistor like we showed at the beginning right there. So I'm going up to the collector with the red jumper, and so right above the orange jumper there, and the emitter right below the orange jumper, because the orange jumper is going to the base. And that's a 10 kilo ohm resistor right there, by the way. So, in any case, there you can see the voltage across the transistor right now. We have 4 volts. That's 1 volt per division. So, that makes sense. We got 5 for the resistor, and then 4 for 9 when it comes to the transistor, 9 total, because we're working with a 15 volt power supply. So you add 6 volts, the 3 series LEDs, and then you got the total of 15 right there. The voltages add up. That's how series components work. Now, what we're going to do is that I think this will still hold true current-wise at 14 volts. It may dip down to like 4.9 something, so it may show 4. But in any case, we go down to 14 volts. There you can see we lost a volt across the transistor. It changed the voltage across it in series with those other components to hold the current steady. So the voltage across the transistor is not setting the current at all. it's changing how much voltage gets across this resistor, which then sets the current. So from the supply voltage, these 4 components are dropping the voltage they need to when it comes to the voltage we set with the Zener dial to hold that Zener voltage minus 0.6 volts, the base to emitter drop, across that resistor. And thus that resistor is what sets the current. Now we can look here and we can bypass an LED. So I'm just going to move this jumper down one spot right there, and there you can see that the voltage across the transistor had to go up about 2 volts right there to hold the current steady. And if I drop another one, again it had to go up 2 more volts, and without any LEDs it's going to have to go up even 2 more volts, which is above the top there. So that's probably 9 volts. We can look at that a little more accurately right there, and you can see it's a 2, 4, 6, 8, and then half of a square right there for one more for a 9. So now that's really the end of the video. We'll come back to the sheet here, which throws off the lighting as far as the camera's concerned. I actually have to increase the overhead lighting and make adjustments to the camera where LEDs on the board actually look dimmer, but the color of the breadboard looks about the same as it did before in the brightness. But there you can see we do have 5 milliamps of current. We still have the 14 volts across there. But the main takeaway is that it's important to look at these voltages when you're building new circuits. And to understand any circuit, really, it's the voltages that are primarily of concern. You limit current to protect components and whatnot, so that's important. But for understanding the circuit itself, it's generally the voltage, what the voltage is doing. So I'm not going to go over all that again. We've gone over what all the voltages are doing in previous videos. This one we just focused on across the transistor. The transistor in this video is basically a self-adjusting voltage drop, and so it basically drops the voltage as needed to keep 5 volts across the supply thanks to that Zener diode, 5.6 volt Zener diode. And so this is the primary workhorse that's doing something interesting in this video, whereas everything else is just doing basic electronic stuff. And that's why transistors are so interesting and can do so many interesting things. They don't behave just like basic components. And in any case, that's it for this video. Check out one of the other videos I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. I put a link down in the description. That would help out a ton. I'll see you in the next video.